This site used to be 4 DMRs. Under that hole in the floor is the governor, and there used to be a little chain-driven Selson motor, and the damper was attached to the end here. Modernised about 20 years ago, maybe, or 15 years ago, to our local controllers with magnetic drives. Give it a run. DSD412, crane or an elevator drive. Keyboard, machine. They don't accelerate quite on the same curve that they used to with the upright generator and regulator with a DMR, because they come in with an S-curve on that. Spent a bit of time hovering around floor though, so any gains were a bit plus and minus. Another run back up. Massive old machines. Say 250 volts. The amps 74.4 amps, 22 horsepower. Roped to 2-to-1. Put a wall here and push one lift up another floor. 4 of these. Over here we've got the chokes and the auto transformers, which is basically the same as what every other lift company did in converting to thyristor drives. This one's a bit quieter than the other one. The bearings are a bit better condition. Ropes are probably about 30 years old. Starting to show a bit of age. Pretty solid machines all in all. It's working. The other one at the end's a bit noisier. Alright, must be the one up here. Look up the stairs. A bit of bearing rumble. This one was lifted up a floor, so they can get an extra floor up. Bit of rope dust there. Bit of bearing noise. Stunning old machines. Stroke on that brake. Under that panel is the governor. That's about it. 4 express DMRs. They used to have H operators. One of the busiest buildings in Wellington. And yeah, now its purpose has changed, but they're still fairly busy lifts. A few embassies in here, and lots of different tenants. So the lifts are not as busy as they were when it was just all one big. Cool stuff. Still painted the express green. The Mark IV selectors on here, and the the Mark IV dispatcher. Controllers used to go right across from one end to the other, with the exception of the trap in the middle. Pretty cool. 100 amp drive, 120 amp contactors, fast brake units, so that the brake lift control is all solid state. Is better with a DC coil. Even got the terminal slowing boards there. They were a requirement in Australia. We didn't have to fit them here, but I think we did anyway because we built the controllers with them. Capacitor dampening, dynamic braking resistors there if your main contactor drops out, just to stop the motor running away. Position control on hex. Push your speed forwards as the lift accelerates. Not bad for a controller that's now obsolete. For some reason, that's the original express phase failure, kept there to switch them over to generator control. So when that supply drops, the contact drops over, puts all the lifts on emergency power, and only one of them runs. I think they would have bought a modern one off the shelf, but the guy that did the job obviously a perfectionist, and beautiful wiring. You could see why he did everything the way he did it. Everything done with relays, and yeah, pretty solid, pretty tidy job. Get another 20 years out of this if they're lucky. DC machines go pretty well because they're kind of over choked, so you don't get the same noise coming through the machines as you would from a direct thyristor drive without the chokes. You still get the hum and the bit of noise. The insulation doesn't stand up as well. If you had shorts in the insulation down to ground when they were generator drives, it wasn't until you got the second short that it was a problem, because the generator output was isolated from earth. Whereas these are off auto transformers off the mains. Go in here and you can actually read the, I think if you select parameter 600, gives you either the speed or the rotation of the machine. You can read the current, the speed, the RPM. Just gonna run. Just thinking about it. Closing its doors. Go. Data 601, one of them was RPM and one of them was, might have been 500 RPM. One of them was the meters per second. We can even get the current reading on here somewhere. The book to know what all the functions were. It's going to go. There we go. One's the speed demand and one's the speed response. Field current, possibly. That one's probably the motor current. Let's see. Go to call. Thinking about taking it. It's probably the voltage on the motor. Looking at it. Pretty solid, these magnetic drives. That one. So you'd have to look at the book. So slamping rate, it's probably the current. Anyway, that's a ULP upgrade mod to a DMR original motor. I think it got new door gear at about the same time. It goes surprisingly well.